Welcome to the project demonstration of IOT wireless matchbox by using PIC microcontroller. So here we have interfaced the LEDs, these high power LEDs, to the microcontroller through the BC547 transistor. So here in our project, according to the block diagram, input modules are ESP8266 and output is LEDs through this switching circuits BC547 transistor. So we are going to provide the signal inputs from the mobile phone application, so to increase and decrease the intensity of these LEDs. So for the commands we are going to use small u and small d. So when we keep on entering the small u, the intensity of these lights will decreases, and small d for decrease and small u for increase the intensity of the high power LEDs. So the power supply is for the whole kit is getting from this one power cable, 230 volts AC inputs, and that is the input to the transformer, so which will step down the 230 volts AC to 12 volts AC, and that is the input to the regulated power supply board, so which will take the 12 volts AC input and provide us a 5 volts DC output from these wires and 12 volts DC output from this one. So it has a 3 stages: rectification to rectify the AC to DC, and filter to remove the pulses after rectification, and from that we'll get the 12 volts peak DC voltage. So that is the input to this transistor board. And after this 7805 regulator, so this is the third stage in RPS, so we will get the 5 volts DC. So that is the operating voltage for Wi-Fi module as well as to our 28-pin motherboard. So on this motherboard we have the 3 major components. One is a 28-pin microcontroller, that is PIC 16F73 microcontroller, and the steel plated one is the crystal oscillator, which will provide us the 20 megahertz of clock frequency to the controller. So the main purpose of this crystal oscillator is, so we are going to execute the set of instructions to read the inputs to control the output. So these instructions will be executed based on the clock pulse. So one instruction, one pulse, so that we are providing 20 mega pulses per second. So controller can execute 20 mega instructions per second. So let us see demonstration. Before on the kits, we need to enable the hotspot in your phone. So go to hotspot settings of your phone and change the hotspot name to project 5380. So project 5380, all are small letters without any space, without any capital letter, and password should be 123456789, and AP band should be 2.4 gigahertz. So these 3 are the very important, and enable the hotspots. And next is install a network analyzer application. So this is the icon in the Play Store, network analyzer application, and a juice SSH. So these 2 important. Network analyzer is to get the IP address of our kits. So now on the power supply, so you can see one device is connected in your mobile phone after you switch on the power supply to the kits. Right, we can see that one device is connected. Now go to the network analyzer application, options, scan, right. So there you can see Express SE. Note down that IP address 192.168.154. Otherwise go to there and select all, copy, and now juice SSH. So when you enter previously, it will show like this. So I'm showing from setting first steps onwards. Type telnet. Okay, so it will show like this, right? And go to manage connections and then add. So they type telnet, 3 changes. Second is type the IP address which we got from the network analyzer application, and the port number is 8080. So these 3 are the very important. Type telnet, IP address which we got from the analyzer app, and port number 8080. Okay, and now click on OK. Right, you can increase the font size by volume up button. So now if I want, initially it will come with the 50% of intensity. So if you want to decrease that, D. So for every input from your mobile application, you can see this LED will toggle, means it will change the its states. Down. So if you want to do that fast, you can go with off, right? And increase is I. So once it reaches maximum level, then that particular LED here will stops changing its state. Right now there is no response from the LED, so that's why it reaches the maximum state. Same thing for down also. Right, there is no response, means it reaches the total zero state. So high state of zero state, the LED won't respond. In this manner we are going to control the light intensity using IoT technology.